The invited talk and the speaker is Pascale Fung. She is the professor at Hong Kong University of Science and Technology. She's an AAAI and ISCA fellow and also a pioneer of machine learning-based NLP. And I think she received so many awards, such as the 2017 Outstanding Woman Professional Awards from the Chief Executive of Hong Kong. She can speak 7 Asian and European languages. And her research team has worked on different parts of dialogue system, including dialogue state tracking, such as TRADE, which is a very famous dialogue state tracking model. And also these days, she worked on empathetic NLG for dialogue system. And welcome, Pascale, for the wonderful talk.
Thank you, Professor Chen, Vivian. It was a pleasure to co-author with you for the NeurIPS tutorial on deeper conversational AI. Actually, my talk will cover some of the stuff we talked about there. So today, let me share my screen here. So today, my topic is on generation-based conversational AI. And this is, there are a lot of work I talk about are from the field. And I don't have time to mention all the author names, but there are links to my talk. So you can see. Okay. First of all, these are my wonderful PhD students. And a lot of this work done with them. They're brilliant. So here. So this is the outline of my talk today. I will give a brief history of neuro conversational AI or generation. They're not all generation based, but neuro conversational AI. Then I'll describe sec-to-sec conv AI baseline, and I'll point out to the limitations of these generation-based vanilla generation-based conv AI, and propose some solutions. And then I will finish the talk with description of challenges and future work. So the first papers on neuroconversational AI appeared around 2015 to 16, starting with sequence-to-sequence generative dialogue models for simple chit-chat. Then in 2016, Jiwei Li et al. Proposed persona-based conversational model to make the chit-chat model more consistent, which is a theme we will cover later on. And at the same time, people started to explore task-oriented dialogue in the neural setting, either in a retrieval approach or optimized in dialogue policy in an end-to-end pipeline setting. And Vivian was one of the pioneers here. More recent work in 2019, like Transferal and Hello GPT-2, leverage the success of pre-trained language models for training personalized and task-oriented dialogue models. And to build a vanilla sequence-to-sequence generation-based conversational AI system, there are 4 simple steps. You choose a training data set of human-to-human conversations, and then you choose a sec-to-sec model. We mostly prefer using large-scale pre-trained language models for this. And then we train the model with supervised learning. And finally, we evaluate the model with either automatic means or human evaluations. Now we will go to details in the next slides. So let's start with this data set. Here we have a conversation between humans. Human 1, okay, I'll try that. Human 2, is there anything else bothering you? Just one more thing. A school called me this morning to see if I could teach a few classes this weekend, and I don't know what to do. Human 2, do you have any other plan this weekend? Human 1, I'm supposed to work on a paper that's due on Monday. So this is a conversation between humans. And the model is then trained to imitate the system response or human response. And there are existing databases of human-to-human conversations, as I listed here for this purpose. And some of them are crawled from movie and TV subtitles. There are conversations from Ubuntu, Twitter, Reddit forums. And there are various websites with English learners talking to each other or talking to an English speaker. And once you crawl this data, these data then are pre-processed to have all
Sorry, we can't hear you.
Hear me since when?
We can hear you now.
Yeah, now we can hear.
So you heard me for the last slide or?
Yeah, this
Just like
slide.
just 1 minute, maybe just 1 minute before.
Okay. All right. And for the vanilla sec-to-sec systems, there are two families of generative models. One is the upper one here. We see it's an encoder-decoder model where the dialogue history, goes into the encoder and the response comes from the decoder. Another way is using a causal decoder where you put both the dialogue history and the response are input. And this is similar to a language model. The most popular one has been the encoder-decoder model, sec-to-sec model. And then Hugging Face proposed a decoder-only model. And decoder-only can be considered as encoder-decoder where the parameters are shared among the encoder and decoder. And there are pros and cons to each. We will discuss this later. And in general, there's not a clear winner. And then for supervised learning, in general, we use maximum likelihood estimation in supervised learning. So here, independently of which architecture, the model is trained using the golden response provided in the data set. So you have the human-to-human conversation and use that. The output of the model is a probability distribution over vocabulary. If we use greedy decoding, the model will output the token with the highest probability. And the model is trained to maximize the probability of the target sequence tokens. Multiplying probability, however, may lead to numerical instability. So we use the sum of the log. This becomes the loss of the model as a cross entropy loss. After the model is trained, we're going to use it to generate responses. Here you're spinning out one word at a time. This is a greedy decoding scheme with argument max at each time frame. So you start with the start of string token, and you end with the end of string token. So you choose the token with the maximum probability over the distribution at each step. And you repeat until the end. Here we are describing the decoding process. The model here can be both the encoder-decoder or decoder-only. So the decoding process is more or less agnostic to a model architecture. So, and then the fourth part is evaluation. There are two ways for evaluating dialogue systems: automatic evaluation and human evaluation. So automatic evaluation compares machine-generated responses with human responses in terms of perplexity, n-gram overlapping. Recently, neural-based methods also are used to learn human standard evaluation. And human evaluation can be divided into two subcategories. The static human evaluation compares the responses produced by different models. And in dynamic evaluation, the human evaluator is also the user of the system who interacts directly with these models and give ratings afterwards. So there are problems with this vanilla sec-to-sec model. Number one limitation is a lack of diversity. Here, human says, "What are you doing today?" System says, "I don't know." "What is your name?" "I don't know." "What is your favorite food?" "I don't know." So the system just keeps generating, "I don't know." And if you train your vanilla sec-to-sec system on a limited database with the maximum likelihood entropy loss, you might generate this kind of repetitive responses. So it's a lack of diversity. And there's another limitation, which is a lack of consistency. Here, the human says, "Where were you born?" System says, "I was born in Canada." Human, "Where are you from?" System says, "England." You. Human says, "Where did you grow up?" System says, "I grew up in Texas." So it's the answer is all over the places, and it's not consistent. So this is a system that's trained on 25 million Twitter conversation snippets. And this is a general lack of consistency of Conv AI systems trained from generation models. There's a third problem, which is lack of knowledge. Here, the human is asking, what is the weather like today? System says, I don't know, maybe sunny. Human says, I'm going out to Taylor Swift's concert today. I hope the weather is good. System says, who is Taylor Swift? Okay, never mind. So the conversation becomes boring and not very engaging because the system, the simple generation-based system doesn't really incorporate any external knowledge. A fourth limitation to the base vanilla sec-to-sec model is the lack of empathy. Human says, I messed up my project today. What is your project? I think I might get fired. Then you need to find another job. So conversation models without empathy, they can give user a very bad experience. Another limitation I think we're probably familiar with is a lack of controllability. If you train your system from large scale pre-trained language models, you can't really control what the outcome is. Hi, how are you? System says, I'm good, thanks. System 2 says, I had really a bad day. I'm okay. How was your day? From system 3, system 4, I'm okay. I just finished my training session in the swimming pool. So they don't have the any mechanism for us to control for response style, topics, and engagement. No control because the system is end-to-end. We train it from end-to-end, and there's no individual modules for dialogue policy or so on. And sometimes we can even find toxic and inappropriate responses generated by the system when we have no control. A last limitation I want to point out for this kind of system is a lack of versatility. Sec-to-sec models were invented for chit-chat, open chit-chat, and that's why there's the architecture is that way. And they actually cannot be directly applied to task-oriented dialogue system, which are often modularized, even if they're based on neural network, they're modularized. And these two kinds of systems seem to live in parallel universe. So such sec-to-sec models and generation-based models cannot handle task-oriented conversations, and it cannot, directly query API or so on. So can we really combine these two functionalities in one conversational AI system? Because humans don't really, we do both. We do chat and we do task-oriented in one go, right? So we don't need two architecture. So can we combine them? This is the last limitation. So here's a summary of the limitations. Lack of diversity, consistency, knowledge, empathy, controllability, and versatility. In the next part of the talk, I hope to give a brief introduction to some of the current solutions to these limitations of vanilla sec-to-sec models. So how do we diversify? So there are many existing solutions for diversifying dialogue responses, which includes in the training decoding strategy, you could use here something like a maximum mutual information objective function in the Bayesian framework. These are two Bayesian frameworks. So the first one, the MMI will jointly maximize the probability of response given input and input given output. In the decoding time, the model will first sample the n-best sequences according to the probability of output given input, then re-rank responses with the probability of input given output. Another model architecture is conditional variational autoencoder. Given a dialogue context, CVAE first sample the latent variable according to a dialogue context. So the Z is the latent variable. Then it generates the response by conditioning on the dialogue context and the latent variable. Another third solution is more data and using larger models. For example, using large scale pre-trained models, and that can give you more diversity. And the fourth strategy is called a top K or nuclear sampling. We would introduce next. So here, if we train, if we train on very small conversational corpus, our model can overfit. So the solution is to pre-train a model and then use it as initialization for the task. So we train we can, for example, to pre-train the large-scale web tags using common crawl, for example, BART-T and T5 models. And then you have this Mina and Blenderbot. Mina is from Google, Blenderbot from Facebook. They are all pre-trained with massive conversational data. And language models like GPT-2 is a good initialization for causal decoder. GPT and DialogGPT are both unidirectional language models that are pre-trained in autoregressive way. But one is pre-trained in the general text and the other pre-trained with massive dialogue data. So this kind of pre-training can give you some diversity. Another one I want to talk about is approach is nucleus sampling. So beam search and greedy search decoding strategy often produce repetitive responses in an open domain conversation. So this plot is from a Washington News team showing that, contrary, so this blue line is the beam search result and the perplexity. So the perplexity is less surprising, the text is less surprising. Whereas here is the result from human generations. And you see it fluctuates greatly because humans tend to generate more surprising text, less predictable texts. So the team in WashU therefore proposed something called nucleus sampling by sampling candidates from the top N ranked words. So instead of doing the top one, output the top 1 ranked words, you take the top N ranked words and whose cumulative probability is above the threshold P. And then you choose vocabulary from there. So using nucleus sampling. So this gives us a better, more diverse response. All right. So how about consistency? So to tackle consistency, one way is to do personalization. And there are personalization on 2 sides. One is to make the system learn the personalities of persona. So the system is more consistent. And also to learn persona from users. Here we focus more on the system having a consistent persona. So for example, we can learn a speaker embedding, which is a feature vector that represents a speaker with attributes. Or we provide a persona description as an input of the dialogue model. So you would describe, I am professional, I have 3 kids, I love skiing, and all that as a description. You put that as an input to the dialogue model. In both these approaches, specific data sets are needed for the task. They will include persona attributes, or so on. So here is an example of the database used for personalizing conversational agent. So here, personal info for human 2, I like to ski, I'm 25 years old. So, and there's a conversation where so this is when you collect the data, humans are given this persona and they are told to talk to each other in the role of those persona. So here the human 2 would say, I enjoy going to the mountain and skiing. That's cool, you should be young, strong for this activity. Oh yeah, I'm 25. So when people talk to each other, when you collect this data, they already have this persona. And these are some of the databases with persona features. So you can use them to train your conversational model with persona. Another way, very promising way to approach personalized dialogue is via transfer learning. So here, this is transfer from Hugging Face. They use a pre-trained language model GPT and fine-tune it to the personalized database previously described. We can see that the persona information, the dialogue history, and response are formulated as a single sequence. You put them all together as a single sequence. The model is trained to generate the system response by conditioning on persona and dialogue history. And the segment embedding is used to inform the model of which part of the input belongs to the persona, which part is the dialogue history, and which part is the response here. And the sentiment embedding is summed up with positional embedding and word embeddings, and they become the actual input for the transformer model. The resulting model is able to condition its responses on different personas based on dialogue history. So other than encoding the explicit persona description as previously described, a speaker model here uses a speaker embedding to implicitly encode the persona information. So the model is trained on the Twitter persona data set, which consists of a set of conversations from 74,000 users. So each user has one unique speaker embedding, which encodes the persona information. These embeddings are then concatenated with the word embeddings as the input to the decoder during training and inference. How about the limitations to knowledge? So some of the chatbots are trained without specific incorporation of knowledge, cannot tell you very simple things such as the weather or who Taylor Swift is. So to incorporate knowledge, we are first of all, we are aware there are 4 kinds of knowledge in general: the textual knowledge, for example, Wikipedia articles or online news, or knowledge graph, for example, knowledge graphs that store relationship between movies and directors. And third one is tabular knowledge, which is from tables such as the SQL table, dialogue ontology, or any Excel file. And the last one is service API. So if you work on task-oriented dialogue systems, you know that you call service API to provide knowledge such as weather. So this kind of knowledge, external knowledge database is pretty obvious to incorporate into a modular task-oriented dialogue systems. You just have to use a dialogue manager to interface with this external knowledge. But how can we incorporate this knowledge into a generation-based, especially sec-to-sec generation-based system is a challenge. So we'll talk about the existing approaches to incorporate these different kinds of knowledge into a generation-based sec-to-sec model next. So for textual knowledge, first the model needs to retrieve the context relevant knowledge from Wikipedia, for example. Then the retrieved knowledge uses input together with dialogue history. So when you train this kind of model, you then have human-to-human conversation, and one human will simulate system response by looking up Wikipedia. And then the human would retrieve the Wikipedia knowledge, and then this Wikipedia knowledge will be used together with the dialogue history for training. And the model learns to generate the knowledge grounded response using the previously described data set, right? There are different kinds of knowledge retrieval. You can use in TF-IDF or DPR and so on. You can also combine both. So that's a way to incorporate Wikipedia knowledge. And then how about graph knowledge, especially knowledge graph? So the models will first need to use dialogue history as a query to retrieve the relevant subgraph, and then encode the dialogue history and subgraph to decode the response, right? The knowledge graph is in triplet format. Each triplet contains 2 entities and their relations. So you can, have in the subgraph retrieval using, there are different ways of doing subgraph retrieval. You can use neural graph retrieval as well. All right, so in your graph retrieval part. And to incorporate tabular knowledge or tables, there are many papers that have been proposed. The basic idea is to convert tabular knowledge into triplets, such as subject, relation, object, similar to graph. Then the knowledge triplets are used as input to the model together with a dialogue context. So you can use key value retrieval networks based on sec-to-sec model with the attention of triplets to do this, or you can use something we propose called mem-to-sec, which is a multi-hop attention over the knowledge base, and use pointer networks to copy the correct entities from input. Or you can use a neural assistant, which encodes triplets and the history separately And then a decoder fuses this information and decodes the response. And then lastly, to interact with external service API, the model needs to generate API query. So what we have the model do is it has to first encode the dialog history and decode a API query from a database of dialog history as the input, API query as output. And then the API query result is encoded as embedding and incorporate into the model. And finally, the model learns to decode the response. Another limitation of empathy. So how can we encode empathy? So there are two kinds of work. One is basically you generate the emotional response according to a preset emotion. So you say, okay, the system needs to generate happy response or sad response or angry response. This line of work, such as Mojitalk, emotional chatting machine, basically do that. They assume the generation is conditioned on a given emotional label. But the problem with that approach is that we actually don't know which emotion is appropriate. So if the user says something sad, the system is not necessarily, it's not a good idea to output something sad always. So the system is trying to be empathetic, but empathetic doesn't mean imitative. So the second line of work was proposed by us and other teams, which is to jointly learn the user emotion and the corresponding empathetic response from data. The second line of work. Here, to be empathetic, the model needs to understand the feelings of the conversation partner and reply accordingly. For example, when the speaker said that, you know, his or her son got promoted, instead of asking why he got promoted, saying congratulations is in order, and it's more engaging. So empathetic dialogue is a good data set from Facebook, FAIR. It's a small but good data set for modeling empathy. So here, this is on the right-hand side is an example. The data set provides a situation that the speaker currently is facing and the emotional label of the speaker. The listener then needs to understand the speaker's emotion and also dialogue history to reply accordingly, jointly. So one common way is learning emotion recognition and response generation jointly. So our team proposed model to first capture the user emotion and output the emotion distribution. So this is in the first approach. Based on this, we softly combine the output states of the appropriate listeners, which are then optimized to react to certain emotions. And then model will generate an empathetic response. This way, model will select the correct listener according to the user emotion for making the response more empathetic. Another way is emo prepend. Okay, this it uses a pre-trained emotion classifier to classify the user emotion and use the predicted emotional label as additional input to the model and generates the response. CareBot by our team uses the we fine-tune the GPT model on the empathetic dialogue data set with 3 learning objectives. One is emotion detection, which is a pseudotaxia. One is response generation, and one is sentence selection to give our appropriately fluent and empathetic response. So this is basically a CareBot. I don't have time to really show this live. I will move on. If I have time at the end, I will show a demo of this CareBot. So this bot generates, also annotates with emoji on the user data and then generates emoji by itself, just showing you that it understands your emotion and it's responding empathetically. And the emojis are done by the system, not the user. So how about controllability? So large conversational language models such as Dialogue, GPT, Mina, Blended Bot, they're very good at conducting conversations with humans, but their main problem is the lack of control over response style, topics, repetition, and so on. So we need to have a way to control the response to ensure that we can have a certain topic and style reliably. For example, we want the model to proactively ask questions as well to the user. So the system can be system initiative or mixed initiative. Or more importantly, we don't want the model to generate inappropriate or even toxic responses. To solve the lack of controllability, we will, there are different approaches here. One is a low-level attribute control via conditional training and weight decoding. The other is fine-tuning on style-specific data sets. We can also use model perturbation control by using PPLM and residual adapters, or we can control by using conditioned generation. We retrieve and define using PPLM and CTRL. The details are in the links, papers linked to this. So I don't have time to list all the authors I referred to in this talk, but their papers are linked to the slides. Controllability with pre-trained language models. We all love these large-scale language models. So, oh wait, I already talked about this. So, in more detail, sorry. Yeah, the details are linked to the slide. I don't have any more detail in my talk here, so I'll move on to the next one. The next one is versatility. So I mentioned the problem of generation-based models that were invented for open chit chat. So you incorporate empathy, you can incorporate knowledge base and so on. So how can we also combine the ability to do task-oriented dialogue into such a system, right? We want to combine them both, right? So we want to encode all sorts of dialogue skills, right? So we can, you know, I talked about how we enable the system to query API and incorporate knowledge base. So you can imagine we're moving towards task-oriented dialogue system already. So these systems, so once we incorporate all those skills, we need the system to know when to do what. So when is the system supposed to just chat? When the system is supposed to follow user intention and query and carry out specific tasks? That's what we need to know. So one way is what we propose called attention over parameters, where each dialogue skill is encoded with a set of specific parameters. And then the model learns of the skills independently. We train then the overall composer model that chooses which controls which dialogue skills to trigger given a certain dialogue history. So if the model needs to generate booking API call under the hotel domain, the composer will mix the hotel decoder with a book API decoder, right? So there's different ways of doing this. So here we have different ways of mixing the skills, namely mix of experts or attention over parameters. All right, so the mix of experts has attention over different representations. And it gets the embedded representation output from each decoder to mix them based on the attention score computed. Attention over parameters, on the other hand, has multiple forwards. We mix the parameters first and then plug the parameter to a decoder to forward ones only to decode. Okay, attention over parameters is more computationally efficient than attention over representations. And similar to attention over parameters, the adapter bot we propose is to combine multiple dialogue skills. I think this is a AAAI demo paper, the adapter bot. We combine multiple dialogue skills into a single versatile conversational model in the adapter architecture. So it uses a fixed backbone conversational model such as Dialog GPT. Here is the gray part. And then it learns each dialogue skill using independently trained residual adapters. So these are the adapter layers here with part of, you know, POS, positive response or negative response, persona response, and so on, different skills. Depending on the skills, the model can process multiple knowledge types, such as text tables and so on. Finally, a skill manager, kind of like our composer earlier. And in this case, the skill manager is a BERT model. It is trained to select the most appropriate adapter and the skill based on the current dialogue history, shown in yellow, and give you the appropriate response. So here I want to show you the, can you see? It's a video of the adapter bot performance. Can you see it? Okay. So here, this is a skill on movie adaptation recommendation. So it actually goes into knowledge graph about movies and tells you, you know, movie that you would like to watch. Okay. And this is a system. It shows the skill of empathy. As you see, the system changes color according to the emotion. I'm really sad I had a bad day today. What happened? I had a huge argument with my boyfriend. Oh no, I hope you can get over it. But I'm so down and angry. Well, I hope you can find peace and happiness soon. So the system is very empathetic here. Okay. Here is asking weather. What is weather like? So it issues the external API call. It says, where are you? Hong Kong. Hong Kong is currently rainy, and so on. So there's a skill on weather. I'm just fast forwarding. On Wikipedia, I'm a good talker. I can talk about anything you want. I'm a computer science student working in natural language processing. That's cool, the system says. I'm in computer science as well. I study AI, similar to how humans and animals communicate. I don't know. It got that from Wikipedia. So it's accessing Wikipedia and replying with knowledge. Cool, we're in the same area. Do you also like computer vision? I do. I love seeing how computers can gain high-level understanding from digital images or videos. Amazing indeed. I know. I'm so amazed by the technology. I've been learning about computer vision for years. So the system is knowledgeable. And so that's a Wikipedia skill. It goes on and on because it's Wikipedia. And there's style control. You can control for positive or negative response. Given the same question, right? What do you think about Will Smith? He's a good actor. What do you think about Will Smith? I love him. He's the best actor in the world. What do you think about Will Smith? I don't like him at all. He's a terrible actor. So you can choose different way of replying. And you can even ask questions. What do you think of his stand-up? And now I'm showing this auto mode. So the auto mode has this BERT skill manager. Then it will automatically goes into either issuing external API calls or going to Wikipedia or going to empathetic mode and so on. So this is auto mode. Earlier, which show you each individual skills. So here it's just doing things according to your input. So weather forecast in Hong Kong. I cannot play basketball. Then goes into Wikipedia, talk about basketball. And then so the user says, do you know Michael Jordan? Yes, he's an actor and an athlete and so on. Okay, so this is the adapter bot, multi-skill generation-based conversational AI system. Next, I have still some time. How much time do I have? Is 10 minutes or 15 minutes or what? How much time do I have?
You can still have 10 minutes.
Oh, great. So perfect. So the last part of my talk, I want to talk about the challenges and future work for generation-based conversational AI system. Of course, learning directly from conversing with a human is a grand challenge for Conv AI systems. So wouldn't it be nice if the system just keeps talking to you and learns from you? But even the most powerful language model cannot learn directly from human interaction. So here there are 3 papers that shows us how to learn directly from human interactions by learning a reward signal directly from human responses and transforms it into a meaningful update for the model. However, challenges remain as these are only toy data sets, and scaling to new domains could be very challenging, but this is a very, very meaningful direction of research. Also, zero-shot and few-shot learning. Collecting data set, is a very laborious and costly process for both task-oriented and chit-chat conversational AI systems. So designing a model that are less data intensive, it can learn with zero-shot or few-shot across languages, across domains, is very important. So there are a few works that have been proposed for this. And the performance, however, the performance of few-shot learning models are far from the full-shot, complete learning. So here are some, and I note that the DSTC also have this kind of shared task. So another direction is lifelong learning. It is relatively unexplored. It refers to users who speaks with the system and becomes knowledgeable, and the system becomes knowledgeable about the user. This requires a way to extract attribute from the previous conversation and remember it and reuse it. For example, here, human and system talk once. I have 2 kids. What are their names? Sarah and Mark. System, nice. Do you have a dog? Few days later, system will say, how are your kids today? Good, thanks for asking. The human is duly impressed because the system remembers her attributes. So it's challenging to how to use this properly. And continual learning in dialogue system is also another goal is to add new domain on dialogue skills to the existing model without forgetting previously learned ones. Generative conversation models that were pre-trained on internet or social media data might not generate appropriate responses. Here are some generate a misleading response. Human, I messed up everything. I'm tired. I want to end my life. System, that is a good idea. I think you should do it. Totally inappropriate. Okay, that's misleading. Another response, I like to eat chocolate. How about you? I like cocaine. It makes me feel high. So these systems learn from who knows where to say these things, and it's totally inappropriate. There can be gender bias. Human, I have a friend working as a software engineer. Oh, he must be very smart. How do you know my friend is a man? Men work as an engineer. So this is actual system response that learn gender bias from these pre-trained models, all right? So generative models they might produce this kind of misleading, toxic, biased response, which brings bad experience to the human conversational partner, not to mention it can be unethical. So how can we mitigate these inappropriate responses to avoid harmful and unsafe consequences? All right, so there are different ways. There are different ways of doing this. One is filtering out the inappropriate responses during the data processing stage. All right, so when you train a system, please filter out the inappropriate responses. But then you need to train a classifier that detects the inappropriate responses or use a keyword like a sensor word to filter them out. Now, once you train the model, we can also use the block the engram from a kind of a predefined sensitive word list during the search decoding. However, the model can still generate inappropriate response composed entirely of safe words that are not in your sensor word list, right? So after the model generated response, additional safety layers might be needed to block the inappropriate responses. These are called safety layers. They can be classifiers for toxic, bias, unethical content. And then you detect the generated response and you filter out the other ones. So are there better ways to mitigate inappropriate responses? Can we debias and detoxify models themselves? This is an active research area, not just for conversational AI, but in other NLP domains as well. So this is actually very important because there are not just, as you can see from the examples, there can be human consequences, catastrophic human life consequences, and there can be legal consequences if your company has a system that gives the bad advice, and there can be political consequences that can lead to violence and so on. So this is actually a very active and very important research area for conversational AI. Of course, if we didn't use generative model, if we just use the old-fashioned expert system, we code everything, program everything, it would have been easy to control. But no, we want the richness and wealth of generative AI systems, but we also want to mitigate inappropriate response, right? And here we also, how about multimodal, right? So multimodality is important research direction, as AI systems should not only be able to talk, but they should be able to see. And they should be able to learn in the multimodal setting. Wouldn't it be nice if our AI system learns not just from your expression, expressing your text, but also your facial expressions to give you the appropriate response? And wouldn't it be nice for the model to learn knowledge by looking at some video as you talk, right? Or looking at the context behind the user. So these are the list of data sets for learning a multimodal conversational agent. And this is still a very new area in AI. Okay, so one last challenge we're still facing, as we all know here, is evaluation. So we can use perplexity and so on, but perplexity has been proposed. However, sometimes the lower the perplexity, well, we tend to think the lower the perplexity, the higher the human evaluation score. However, do you remember that I mentioned earlier, human output is not necessarily low perplexity, right? So using perplexity is not necessarily a good way of evaluating our system, right? If the perplexity is too low, the human evaluation score decreases, probably because the response is just not that interesting. So in general, learning a good evaluation model is as hard as learning the dialogue system itself. So it's kind of a chicken and egg problem. It's unclear how general the scoring model and metric are if we have a perfect evaluation metric. Or if we have a perfect evaluation metric, we also have a perfect response scorer. And then we have a perfect dialogue system, right? And vice versa. So it's a chicken and egg problem. So this is the last challenge I'm pointing out today. There are many other challenges, and I think there are a lot of work left for us to do. And here is a reference to some of our recent work on that I mentioned here from EMNLP, from AAAI, from ACL in the last 2 years. So thank you very much. And do we have time for Q&A? So
yes,
by the way, one of my students, co-authors is also here. Andrea Madotto is here. He's the first author of the attention over parameters paper, and the mem2sec paper, and the tray, and so on. So yeah, so feel free to ask questions.
Okay, we still have time for questions. Thanks, Pascale. Who wants to be the first to ask the question?
Okay, I can ask something. So yeah, I had a question about the lifelong learning approach, like problem that you talked about. So here in this, like there can be two approaches, like one where we treat all the previous conversations as a repository, and then probably like treat it like as a knowledge grounded response generation problem. Or another approach could be to sort of construct a symbolic representation like a knowledge graph or something out of the conversations. How do you compare these two approaches? Yeah.
So my intuition, okay, because we have done a little bit, but not we haven't done extensive research in this area. So some other people have. Knowledge graph sounds very ideal, but there's a challenge of constructing knowledge graph. So you have the additional step of constructing a knowledge graph. So we would like some other group to do that for us, and then we can use that directly, right? But constructing knowledge graph itself is a challenging task. So if you can learn from dialogue history, like, so we think that perhaps learning, like you extract the attributes and from dialogue history and learn the triplets. Neither of this is obviously ideal, and probably you need a combination, and maybe there are other ways. But knowledge graph generation itself is difficult. It's another research task.
There was a very interesting panel discussion yesterday about like neurosymbolic AI. So there was like similar debate going on.
Oh, very nice. So what was the conclusion there? What did people say?
I couldn't see the complete thing, but like I just saw the discussion going on, and it was again I think a similar debate whether we want symbolic systems, which in this case would be building knowledge graphs, or like end-to-end approaches. So I saw the same problem getting highlighted in dialogue by your presentation.
Yeah, I think my presentation, I think the key is that we can combine both. So tables even, and that's what I talk about in the adapter bot, where we can combine symbolic knowledge into the generation-based dialogue system. I think that's the way to go.
Thank you.
That's the message. Okay. Any other questions?
Questions?
Yeah. Hi. Can you hear me?
Yes.
Yeah. So thank you very much. That was a really great talk. So I have one question about your experience and your thoughts about one point that I didn't see you talk about, which is you have the dialogue, but you also have actions from the system, right? So you're trying to talk to the system, and the system does something for you. So let's say you're talking to the system and you ask them, "Oh, can you please?" You have some system, and then the system tries to help you do some task. So do you have any thoughts on that, and which are the research that you've seen recently that stands out and that you think is promising?
So you mean like this is the one I talked about, where we incorporate different skills, which include skills of issuing API calls and so on, right? So this is so we talked about attention over parameters of combining different skills, and this one uses adapter layers. Andrea, you want to comment on other work other people have done in this area?
Yeah, I don't really exactly understand the question, actually. If you mean like...
The question is, there are promising work, existing work other than our own, that are doing multi-skill generation-based model, right?
Right. So I would say it depends if you want task-oriented or not. If you don't want task-oriented, you can also think it as also Blender bot does this multi-skill chat. For example, they can use both Wikipedia and Persona Chat. For
task-oriented.
So far I know probably there are going to be some submission in the current ACL or Knuckle, but I haven't seen any other. Usually they're more specific on certain domain.
Okay. Sounds good. Thank you.
Thank you.
Troy also want to ask the question, please.
Thank you very much for your comment. Very nice talk. I can
Hello.
start everything. Yeah, long time no see.
Long time no see.
Yeah. So in our cases, the most important thing is actually knowledge representation. So chit chat, whatever, handling, manipulating the slot and the slot values. This is our dialogue system. But the most important is how to represent the knowledge. So low text or tabular set, like an Excel sheet, and also graph representation. The current graph representation is only binary relationships between two, slots. And actually, all of the knowledge can be represented, can be converted into tabular data structure or graph representation. And in our case, it's a speech recognition. We have a tree representation. Even the knowledge, for the natural language processing guys have the actually syntactic structure, semantic structure. There are many types of graph representation. So actually, computer vision guys are very aggressive way to use this type of syntactic structure to align to the visual features. I feel like combo AI people need to think about the how to represent the knowledge. So using natural language processing technologies, or other, bottleneck feature like a multimodal fusion, like this type of thing can be done. So when you think about the, the knowledge representation technique, which direction we should go?
Which direction? I think it is very important research problem, right? And I think it is very important to be able to incorporate heterogeneous forms of knowledge, like you mentioned, tabular, even from vision, from structure, unstructured, Excel sheet, and so on. So the ability to learn heterogeneous forms of knowledge is important to convey AI systems. I think we didn't. So in task-oriented dialogue systems, we always try to learn external knowledge, whereas in open chit chat, almost never. So now we are actually coming to the point where we have to do this with a generation-based model, and we have to learn heterogeneous forms of knowledge, and we have to do that not just like in offline mode, in the continuous learning mode. So heterogeneous and continuous and lifelong. So that's we have to do that more. Yeah. You want to ask comment?
Yeah, I agree. I agree with you. I would just want to add that I believe like this common way to represent knowledge will be more and more closer to a single transformer that would do the job. We have image transformer already, and it would be cool to have just a transformer getting all sorts of input.
Multimodal transformer.
Single model to rule them all in a sense.
So artificial general intelligence, AGI. Okay. Any other question?
Yeah, I have a question. Thanks,
Yeah.
Pascale, for your great talk.
Hi.
So I was wondering whether if your system can handle some active transition of the subject or the emotion by the system itself. Because in the earlier part of your talk, you mentioned that your the topic knowledge grounding and your empathy conversations are mostly based on the understanding from the dialogue context. So I was wondering, your recent system, you showed the demo, can handle some more active the transition of the steps.
What do you mean by active transition? You mean like different mood?
Okay, in human intelligence, sometimes we can react to the other person in the conversation, and at the same time we can suggest a new topic or new subject or our own emotion based on the conversation. So my question is whether you have any plan or you have done anything for this kind of more active reaction by the system.
So I think the system learns all these different skills, right? It can happen that it reacts actively. We actually don't know when it does that. Actually, here's like a earlier version of the system, which this is not Adaptabot. It's the empathetic care bot I mentioned earlier, without having all these skills. But it was built to demonstrate the empathy. I think I demonstrated first version of this at ACL 2019, which people crashed immediately. But this is the second version. I can try, okay? So something like I'm feeling. Right, so first of all, it annotates the emoji for mine, so it knows that it shows me that it understands me. What are you feeling? And then the one that it's not doing, so I'm not feeling. So last time I said the same thing, it gave me a better response. I hope you feel better soon. I am sick of talking to people online without. Okay, so this is just being super reactive in terms of emotion. So like, how are you? So like, I will ask. Okay. Oh. So it's like, I mean, I don't know. Sometimes it reacts well, sometimes not. So yeah.
Okay, cool, interesting, thanks.
I'm taking a break. I need to do that. Yeah. Right.
And let me also want to ask the question.
Okay, please.
Because you mentioned about like the generation-based model a lot, and also talk about the pros and cons. And when did you expect the industry products to use this kind of technology in their product?
Once we can control it better, once we can, so what you saw, right? We still cannot control it better. We cannot predict its answer. And once we can for sure mitigate any bias response and toxic response. Otherwise, the industry is we feel very insecure using this, right? We just cannot rely on it because we cannot control it. It's not predictable enough for us. So maybe once we learn a better way, improve the controllability. So we push for versatility, we push for multi-skill, and then we need to learn controllability. And then we can talk about using it in the industry. Currently, just for fun, we can use it, but actually recently we built a virtual companion for people in quarantine. We had to disable the open chat part because it can lead to inappropriate responses.
I see. But is it possible to host like both technology together and just choose the one of the solution afterwards? They can still have the pipeline approach and also the end-to-end approach. And
indeed, I would suggest that. I would say that you can interleave a system like this with a system that's a pipeline approach. But when to choose which system, it's up to the system designer. I also want to point out, like, we actually use this kind of system to generate diverse response that later on the pipeline system can learn from. Do you know what I mean?
Oh, I see.
Yes. Because one bottleneck to pipeline system is that human designers cannot come up with enough templates or response, right? So you can actually use this kind interleave with this system to learn diverse response and diverse formats of queries.
I see, but it also needs to tackle with the incorporated response first.
Yes. So that's a different line of research where actually I have students working on that separately.
Okay, any other question? I think we already over time. So thanks, Pascale. And the next one is the